They found something 12,000 meters beneath our feet that scientists said was impossible. Something that changes everything we thought we knew about life on Earth. No, it wasn't aliens or a hollow Earth filled with dinosaurs, though what they actually discovered might be even more mind-blowing. In the next 12 minutes, I'm going to show you what humans really found at the deepest point we've ever reached inside our planet, a place fewer people have visited than have walked on the moon. You're about to see how we drilled nearly 8 miles straight down, what bizarre life forms exist in these impossible environments, and why what we found down there was so shocking it made scientists question everything about our planet's interior. By the end of this video, you'll understand why some scientists believe what's beneath your feet right now could completely rewrite our understanding of Earth's history and potentially solve our energy crisis. Make sure you watch until the end for the most unexpected discovery that scientists are still struggling to explain today. We've spent billions launching humans into space. We've mapped distant planets, photographed black holes, and sent rovers to Mars. But here's the shocking truth. We've explored more of the moon's surface than we have of Earth's deep interior. Think about this. If Earth were an apple, we have barely scratched the skin. The deepest humans have ever drilled is 12,162 meters, less than 0.2% of the distance to Earth's center. That's like claiming you've explored the ocean after dipping your toe in the beach.
Which would you rather explore? Deep space or deep Earth? Tell us why in the comments.
Yet what we've found in this tiny fraction we've explored has left scientists stunned and questioning some of our most fundamental theories about the planet we live on. Humans have always been obsessed with what might lie beneath our feet. Ancient civilizations imagined underworlds filled with gods, demons, or the dead. Today, we're still driven to dig deeper, not by mythology, but by questions that could reshape science itself.
There's something primal about wanting to know what's down there. Throughout human history, underground spaces have represented both our deepest fears and our greatest possibilities, where we've hidden treasures, buried the dead, and imagined entire realms existing. It's no wonder we're still compelled to look downward.
But before we reveal what scientists actually found 12,000 meters down, you need to understand what they were drilling through. The amazing structure of Earth itself that most schools get completely wrong. This is how most textbooks show Earth's interior, perfect uniform layers like a bullseye target. It's also completely misleading. The reality is far more chaotic, dynamic, and fascinating. Earth isn't a static ball of rock. It's a planetary-scale engine constantly reshaping itself from within. Imagine Earth as a peach. The fuzzy skin, remarkably thin compared to the whole fruit, represents Earth's crust where we live. On land, this crust averages just 30 kilometers thick. If Earth were a basketball, the crust would be thinner than a credit card. Even this thin crust isn't uniform. Continental crust, the land we live on, reaches depths of 30-50 kilometers. Oceanic crust under our seas is much thinner at 5-10 kilometers, but denser. Every mountain, earthquake, and volcano results from these crustal plates colliding and grinding against each other in super slow motion. Beneath the crust lies the mantle, extending about 2,900 kilometers down and making up 84% of Earth's volume. Hollywood shows the mantle as bubbling lava, but that's completely wrong. It's mostly solid rock under such extreme pressure and heat, 500 degrees C to over 4,000 degrees C, that it becomes plastic-like, flowing at rates slower than your fingernails grow. If you could watch the mantle move in super fast motion, speeding up millions of years into seconds, it would flow like thick honey. This incredibly slow churning literally reshapes our entire world from below. At Earth's center lies the core, a metallic heart primarily composed of iron and nickel. The outer core is liquid, while crushing pressure makes the inner core solid despite temperatures matching the sun's surface, around 5,500 degrees Celsius. This core generates Earth's magnetic field, which does far more than just make compasses work. Without this magnetic shield, solar radiation would strip away our atmosphere like it did on Mars. Every time you use GPS, see the northern lights, or simply walk outside without radiation poisoning, you're benefiting from Earth's core doing its job.
Most people have no idea how directly connected they are to Earth's core. The magnetic field it generates is literally what allows us to exist. When you look at a compass, you're essentially communicating with processes happening 6,400 kilometers beneath your feet. So what happens when humans try to penetrate these layers? The answers will shock you and might completely change how you think about what's beneath your feet right now.
In 1961, America launched Project Borehole with a goal that seemed straight out of science fiction: drill through the ocean floor to reach the mantle. Spoiler alert, they failed spectacularly, but what they discovered instead was almost more valuable. Using a converted Navy barge near Mexico's coast, scientists managed to drill just 183 meters into the ocean floor, less than 1% of their goal. Yet even this failure revolutionized Earth science by proving deep ocean drilling was possible. The real hero of Project Borehole, oceanographer Elizabeth Corwin, a pioneering woman scientist whose contributions were largely erased from popular accounts. Her analysis of microfossils from these cores revealed extinct species and ancient ecosystems millions of years old that no human had ever seen before.
Did you know a woman scientist made one of the biggest discoveries from Project Borehole? Share this video to spread her untold story.
But the true champion of deep drilling emerged during the Cold War. In 1970, Soviet scientists began the Kola Superdeep Borehole project on Russia's Kola Peninsula near the Norwegian border. Americans focused on reaching space. The Soviets were going in the opposite direction, and what they found down there was absolutely mind-blowing. By 1989, they had reached an astounding 12,262 meters, about 12.3 kilometers or 7.6 miles down. That's so deep that if you placed Mount Everest inside this hole, its peak would still be 3 kilometers underground. To this day, no one has drilled deeper. What they found defied all scientific predictions. First, they discovered water, not just moisture, but actual flowing water at depths and temperatures where it should be impossible. This wasn't ordinary water. Scientists estimated it was over 2 billion years old. Water that had been trapped in rocks since before multicellular life existed on Earth's surface. Even more shocking, they found life. Microscopic organisms thriving at depths of 6 kilometers and temperatures of 180 degrees, 356 degrees, conditions that should destroy all biological molecules. These heat-loving microbes weren't just surviving, they were thriving in an environment that would cook any surface organism instantly.
Before Kola, we thought life had clear physical boundaries. What they found down there completely rewrote our understanding of life's limits. These weren't just a few hardy microbes, there was an entire ecosystem thriving in conditions we thought were completely sterile. It makes you wonder what else might be living in places we've assumed are lifeless.
The project revealed other major surprises. Rock at these depths was far more fractured and saturated with water than any model predicted, and temperatures increased much faster with depth than expected, forcing scientists to completely revise their thermal gradient models. Since Kola, other major drilling projects have probed Earth's depths. Germany reached 9.1 kilometers in Bavaria. Japan's Chikyu vessel has extracted cores from 3.2 kilometers beneath the ocean floor. And in 2019, Scientists drilling off Japan found microbial life at a record 2.5 kilometers beneath the seafloor, in rocks over 20 million years old.
Scientists found 2 billion-year-old water and living organisms where nothing should survive. What do you think they'll discover if we go deeper? Down.
While modern drilling gives us narrow glimpses deep into Earth, humans have been creating vast underground spaces much closer to the surface for thousands of years, with equally mind-blowing discoveries that most people have never heard about. Hidden beneath the hills of Turkey's Cappadocia region lies Derinkuyu, an underground metropolis that would make modern engineers jealous. Carved from volcanic rock, this 18-level subterranean city could house up to 20,000 people and their livestock. Roughly the population of a modern small city, all completely invisible from the surface. Dating back at least to the 8th century BCE, Derinkuyu wasn't just big, it was a defensive masterpiece. Each level could be sealed off with massive stone doors weighing up to 500 kilograms, about the weight of a grand piano, rolled into place from the inside. The city included everything needed for long-term survival: wells, ventilation shafts, storage rooms, churches, schools, and even wineries. What blows my mind about Derinkuyu isn't just its size, but its sophisticated engineering. They solved ventilation, water access, and waste disposal problems that would challenge modern architects, all without power tools or computers. The ventilation system alone is a work of genius, maintaining airflow through hundreds of shafts while preventing enemies from poisoning the air supply. Even more shocking, Derinkuyu isn't unique. Over 200 underground cities have been discovered in this region alone, connected by tunnels stretching kilometers. Some archaeologists believe we've found less than half of the total underground network. Beneath the romantic streets of Paris lies a completely different kind of underground marvel. Over 300 kilometers of tunnels and chambers lined by the remains of approximately 6 million people. That's more than twice the current population of Paris itself, all carefully arranged underground. By the late 18th century, Paris was literally being poisoned by its own dead as cemeteries overflowed. Beginning in 1786, remains were disinterred and transported at night through the streets to these former limestone quarries. Workers spent 12 years moving bones, creating the world's largest ossuary and saving the city from disease. Would you live in an underground city if you had to? What modern conveniences could you not live without? Tell us below. In China's Gansu province, the Mogao Caves represent yet another underground achievement that few people know about. Imagine 492 temples carved directly into cliffs, containing over 45,000 square meters of murals. That's larger than 6 soccer fields of ancient artwork, and more than 2,000 painted sculptures created over a millennium. These ancient achievements, while closer to the surface, show humanity's enduring relationship with the underground. Today, this relationship continues with engineering projects that make these historical examples look like amateur hour. Beneath the border of Switzerland and France runs a circular tunnel so precisely engineered it defies belief. The Large Hadron Collider's main ring maintains a circumference accurate to within 1 millimeter across its entire 27-kilometer length. That's equivalent to hitting a golf ball from New York and having it land in a specific cup in Los Angeles. At 175 meters deep, the LHC isn't the deepest human structure, but its engineering makes it arguably the most precise. Inside this tunnel, protons race at 99.9991% the speed of light, fast enough to circle Earth 7.5 times in a single second, recreating conditions from just after the Big Bang. Jin Xiaoting, CERN engineer, we created the coldest place in our solar system right below people's feet. Parts of the LHC are kept at 271.3 degrees, that's colder than empty space, while just meters away, powerful electronics generate enormous heat. Most people driving overhead have no idea what's happening beneath them. Below Tokyo lies what might be the world's most impressive urban underworld. Beyond its labyrinthine subway system, massive flood control systems protect the city from increasingly severe typhoons. And what they built to do this will absolutely blow your mind. The Metropolitan Area Outer Underground Discharge Channel features 5 massive silos connected to a tank so large it's nicknamed the Underground Temple. This cavernous space, 177 meters long and 78 meters wide, is supported by 59 concrete pillars, each weighing 500 tons. During heavy floods, it can pump 200 tons of water per second, enough to fill an Olympic swimming pool every 1.5 minutes. Tokyo's underground temple can pump enough water to fill your house in seconds. Tag someone who needs to see this engineering marvel. Ishikawa Kazuko, hydraulic engineer. The first time I saw the completed main tank, I couldn't believe humans had built it. It looks like something from an alien civilization, but most Tokyo residents have no idea it exists beneath them. They just know their homes don't flood anymore. And what's scarier, we're already designing bigger systems because climate change is making our current ones insufficient. In Switzerland, the Gotthard-based tunnel stretches 57.5 kilometers through the Alps, making it longer than the English Channel Tunnel, and reaches depths of 2.3 kilometers. Completed after 17 years of construction and costing $12 billion. It's currently the world's longest and deepest rail tunnel. Tunnel boring machines carve through 73 different types of rock while overcoming temperatures of 47 degrees Celsius and water inflows that could fill 20 bathtubs every second. The project excavated enough rock to build 5 great pyramids of Giza. But for sheer depth, nothing beats South Africa's Mponeng gold mine, which reaches a staggering 4 kilometers below the surface. At these depths, rock temperatures hit 66 degrees, 150 degrees, hot enough to cause fatal heat stroke within minutes without intervention. To make working possible, an extensive cooling system pumps slurry ice underground, consuming enough electricity to power a small city just to keep the mine cool enough for human survival. Even with this system, miners can only work limited shifts in the deepest sections. At these depths, you can literally hear the earth. The rock makes cracking sounds as pressure shifts around you. We've found fossilized bacteria in water pockets that have been isolated for millions of years. People talk about exploring Mars, but we have an alien world right beneath our feet that we've barely begun to understand. While commercial interests drive minds ever deeper, scientific curiosity continues pushing our understanding of what lies far below. And what they're discovering might completely change our understanding of Earth itself. This is Japan's Chikyu drilling vessel, humanity's best hope for finally reaching Earth's mantle after 60+ years of trying. With its 121-meter-tall derrick and advanced riser drilling system, it's designed to eventually reach depths of 6 to 7 kilometers below the seafloor. Project Mohole to the Mantle, M2M, aims to drill where oceanic crust is thinnest, about 6 kilometers compared to 30+ kilometers on land. Success would give scientists their first direct samples of mantle material in its natural state, potentially answering questions that have puzzled geologists for centuries. The mantle makes up about 84% of Earth's volume, but we've never seen it directly. It's like trying to understand an elephant when you've only ever seen its toenail. Every prediction we make about the mantle is based on indirect evidence. Direct sampling could confirm or completely overturn our most fundamental models about how Earth works. Scientists have never seen 84% of Earth directly. What do you think they'll find when they finally reach the mantle? Beyond geological understanding, deep exploration has completely transformed our concept of life itself. The Deep Carbon Observatory project has documented thriving microbial communities 5 kilometers down, surviving on chemical energy rather than sunlight. These discoveries suggest Earth's biomass may be far larger than previously thought, with potentially up to 70% of all bacteria and archaea living underground, completely isolated from the surface. What's mind-blowing isn't just that these organisms exist, it's what they can do. They've evolved enzymes that function under conditions that would destroy most biological molecules. One strain we isolated produces compounds that break down toxic pollutants at temperatures where conventional treatments fail completely. The potential applications range from environmental cleanup to novel medical treatments. Some of our most advanced physics research also happens deep underground. Neutrino observatories buried kilometers down use Earth itself as a shield against cosmic radiation that would otherwise overwhelm their sensitive detectors. Every second, trillions of neutrinos pass through your body without interacting with it. To catch even a few, we need these massive detectors buried deep underground where other particles can't reach. It's like trying to hear a whisper during a rock concert. You need to eliminate all other noise. What we're learning about these particles could eventually explain why matter exists at all. The future of deep exploration will likely rely less on human presence and more on advanced robotics. Projects like robo-miners are developing autonomous robots that can navigate, analyze, and extract resources from areas too dangerous for humans, potentially allowing us to reach depths we've only dreamed of. Meanwhile, NASA's planetary deep drill prototype, designed for exploring Mars, is being tested in Earth's extreme environments. These technologies may someday help us answer whether subsurface life exists on other worlds by drawing on our experience, exploring our own planet's depths. From ancient civilizations carving cities into rock to modern scientists drilling kilometers beneath the seafloor, our journey beneath Earth's surface reveals something profound about both our planet and ourselves. Perhaps the most shocking discovery from our deepest explorations isn't the 2-billion-year-old water, the extreme-loving microbes, or even the unexpected geological formations. It's the realization that the traditional picture of life on Earth, the one we all learned in school, scientists now believe the majority of Earth's biomass may exist underground, not on the surface. The total weight of underground microbes could be hundreds of times greater than all surface life combined, including humans, animals, and plants. We're not the dominant life form on Earth. We just happen to live in the thin surface layer where we can see the sky. Each expedition beneath the surface reminds us how little we truly know about our own home planet. We've mapped distant galaxies in greater detail than Earth's interior. We've spent billions reaching space, while the ground beneath our feet remains largely unexplored. Going deep underground may be the closest experience we have to space travel. Both environments will kill you without technology. Both require bringing everything needed for survival. Both push us to engineer solutions to problems we can barely imagine beforehand. The difference? Space has better marketing. What's remarkable isn't just how deep we've gone, but how our understanding has evolved. Ancient cultures imagined underworlds with spirits or gods. Today, we find different but equally wondrous things. Life forms that redefine biology, water older than humanity itself, and rocks that tell Earth's origin story. This video literally changed how I think about Earth. What fact surprised you the most? Drop a if you watched until the end. The quest continues with new technologies and methods. Projects like Japan's Chikyu may soon give us our first direct samples of the mantle. Underground laboratories continue probing fundamental physics, And with each meter we descend, we discover how incredibly complex our planet truly is. And that may be the ultimate lesson from our journey 12,000 meters down. Whether looking to distant stars or into Earth's depths, we're driven by the same fundamental question: what is our place in this vast, complex universe we call home? The answer, it seems, lies in continuing to ask the question and continuing to dig deeper. Subscribe for more mind-blowing science videos that will change how you see the world. Hit that notification bell so you don't miss our next exploration.